Hello guys, today we will see how we can convert this 2D X-ray CT scanned data to a 3D object like this. So there are multiple software which can be used to convert these 2D files into 3D objects, but the most efficient one I found is to be the Slicer software. So we will just open the Slicer. So this is how the software would look like. Here we have three blank screens over here. These three blank screens represent RGUI, that is a medical term. So basically what we want is the top view, the front view, and the right view, the right side view, and this will be your isometric, your 3D coordinate. So now what we will do is we have to import these 2D images into these three separate lanes. In order to do that, firstly we need to make sure we only want this object from the image. So we need to cut out the object from the image. So we don't want this white bars over here to be showing up in our 3D model. So what we should do is download a software called Irfan View, which is really helpful to convert this batch files, because normally this CT data are hundreds of images. As you can see in this file, there are hundreds of images, so you can't crop each and every image manually. So this Irfan View software would be really helpful to do that using a batch conversion method. So once you install the software and open the software, this is how it would look like. You just need to put your mouse up at a corner, left click and drag. You will see a bounding box around your object. So just carefully align it with the object like this. So I'm currently selecting entire image, as much as the image as possible, so that we'll get a pretty good boundary. So this is a boundary I got. Now we need to start the batch conversion. For that, we'll go to File, Batch Conversion and Rename. And in here, we will select the image format as TIF, as we need the height, length, and breadth the data from the image. So now we'll select the advanced options and check the crop and get current set. So what it does is it sets the current box bounded pixel region into this XY positions. So hit OK. Now select add all, so that all the images from the sequence will be adding up here, as you can see. Now select any folder. I'm selecting desktop F crop. I named the folder like that. So now we just have to start the batch. That's it. So it's going to take few seconds of time to run the batch conversion, as you can see here. So that's done. 340 images, everything is done. So exit the batch, done. And after the cropping, this is how it should supposed to look like. Fine. There's one extra image that we don't need. I'm deleting it. So now this is the sequence. Sequence looks pretty good. So now what we need to do is we need to open up these files into the Slicer software. So there's one easy thing. What you will do is just select the first image, all right, and just drag and drop this into here. And once you drag and drop, you will see this import menu. So in that, click show options and uncheck this single file. Okay. So now, as you can see, our images have been loaded up. The software automatically recognizes the front, right, and top view. But as you can see here, the dimensions are altered. So to correct the dimensions, what we need to do is we need to go back to the original file settings. Okay, I'll go to the original file. Okay, here. Now, as you can see, our file has 3.82 mm. That is the scanning layer length. The scanning layer depth. So the CT scan, it scans a layer by layer method. So every layer, the distance is given like that from the bed. So bed is 0, the machine's bed is its origin, and the top is its top dimension, this object top dimension. So if you scroll every image, you can see this number changing. So it is 3.82 mm, now it is 3.77 mm, 3.71 mm. So there's a constant length change. So that length is 0.06 mm. So we got one axis length, so now we need to give that particular value to these coordinates. So now to give those values, select this drop down menu over here in the top left corner, and now select volumes. In the volumes, drop down volume information, and as you can see, the XY coordinates are already given properly according to the image. That is the reason why we exported this image in a TIF format, so that we don't lose the dimensional data. But as you can see, the Z axis is given as 1 because that is a manual one. So that is the manual one which we got is 0.06 mm. Fine. So you cannot see the object. Where did it go? It just crushed it like that. So to view the object in the middle of the viewport, you hit this button over here. Fine. Now everything is in order. But as you can see, the Y and the X and Y seems to be compressed. So that is why why it happened is because the software has some kind of issue with recognizing the scale properly. So the scale is multiplied 10 times. So in this particular case, I found it to be 10 times magnified. So I'm going to divide 10 times. So every axis I'm gonna 0.02 and 0.02. As you can see, if you're taking any square or rectangular object, so that is supposed to be your this length. It is supposed to be equal in the range of this. So 0.06. So it is supposed to be in the range of 0.0 xxxxx. So like that it is supposed to be. So 0.0264, and that's it. So now as you can see, fine. Okay, now it looks pretty good. Now what we have to do is to convert this the 2D image into a 3D volume. So just to view how it's going to look, we will go to segmentations, create a new segment, add a segment. I'm going to name this as F object and enter. And now what we have to do is edit the selected threshold over here, threshold. And when we press threshold, we can see the green outline over here. That is basically it is selecting all the white colored areas of the image. So that is our object image. This image is of a metal foam. So these are the cell walls. So it is selecting the cell walls because of its white color. So if you want to zoom in, press Ctrl and scroll your mouse wheel, as you can see like this. Now select the left hand corner of this slider and pull it to your left side, so that you increase the thresholding value. As you can see, I'm connecting all the open-ended areas. But as you can see in the other two images, there are a lot of dots coming up. That is basically the noise. So we don't want the noise to damage our 3D model. So what we'll do is adjust the threshold properly, just where we eliminate the noise entirely. So this looks perfectly fine. Yeah, as you can see, very little noise, and almost all the white colored area is selected. So now what we'll do is, here scroll down a bit, here this is apply. Now you hit apply. That's it. Now comes the main part where we create a 3D object from this. So depending on your hardware, it might take you from about 15 to 20 minutes to somewhere about 2 to 3 hours, depending on your hardware. So now what we should do is press this show in 3D button. Just select it and hold on. the software is going to take a lot of time to convert this thresholded 2D image into a 3D object. So we'll wait for a few minutes and let's see how the result is going to turn out. Okay, now we got our 3D model. As you can see here, you have to scroll your mouse wheel down to zoom in order to zoom in. Nice. And hit the center button. Nice. Now as you can see, our model has been converted into 3D, but there's a lot of noise particles around in here. So for that, we need to go back to the threshold again and check where we actually got this kind of problem. And so 26 is just too much, I guess. So I will push a little bit, maybe 20. Yeah, I'll go with the 20 right now, and then I'll hit apply. All right. Now, as you can see, it's a little bit clean now. As you can see, it's much more cleaner than the previous edit. So it is pretty good. Now you can see this is the 3D model which we got from this image. So, well, I think we can clean it up a little bit. So let me just maybe about 24, 22, 25, maybe. Yeah. Okay. So as you can see here, now it's pretty fine. Yeah. Yes. Now as you can see, it's looking really, really good. Really nice. Okay. So now we will export this 3D object as an STL file format or an OBJ file format, whichever suits the need. So if you want to go ahead with the analysis part, STL is the preferred export method. But if you want to just show it off as a 3D model and just use it as a 3D object, then OBJ is the best one. So now we'll export, but here there's one important factor we should be considering right now is the file size. So normally the STL file formats of regular SolidWorks design would be about 1 MB at max, but if you export this data directly, the file size is going to be pretty huge, about 1 to 2 gigabytes. So we don't want that amount of memory to be consumed, because it'll complicate the computational part during the analysis. So for that, we need to reduce the file size. So how we can do it? For that, we need to go to the segmentation over here, and as you can see in this closed surface, click on update, and now select the first one as it is our object, 3D object. Now in here, there is something called as decimation factor. What it does is it reduces the number of polygons which is used to construct this 3D model. So as you can see, desired reduction in the total number of polygons ranging 0.0 decimal to 1, as much simplification as possible. Value of 0.8 typically reduce the data set size by 80% without losing too much detail. So we will select 0.8 and hit convert and wait for a few minutes. Depending on your hardware, you need to wait for a 30 minutes to 1 hour. Okay, now as you can see, our 3D model is finally done. The decimation process is also complete, and you can see there's not much of a difference in the model here, but there is a lot of reduction in the file size and the polygon count, which would be really helpful when we go for the analysis part. So now that's it. So now here we come with the final part. In the same segmentation panel, we'll go down to the export to file drop down menu, select that, hit on this selection menu to for the destination folder. I'm going to select something in the desktop, exported F object data. I created the file. Now choose it and select STL or OBJ. Both of them are really helpful. OBJ only when you want to showcase this as a 3D object. STL is used for 3D printing, or if you want to use any other software such as SolidWorks or Meshroom, you can convert this STL file into a solid object for the analysis part. So we will select STL and export. Well, as you can see, is this has about 366 megabytes, so that is pretty good. All right, as we now converted this 2D image into a 3D model, there are a number of ways to use this 3D model for analysis. The best way to use this 3D model for analysis is using SolidWorks. The SolidWorks has an amazing feature of converting this surface mesh into a solid object. So if you want to use this model for analysis work, I would recommend you guys to use SolidWorks, as it saves a lot of time while converting this 3D model to a solid object, for which you can add materials and mechanical properties. Thank you for watching the video, guys.